2, the rationalizing technique. So in the previous video we looked at a dividing out technique, and now in the rationalizing technique what we're going to need to do is either rationalize the numerator or the denominator, which I know is unnatural for you. So far you've only rationalized denominators in your life. That's where we've made it so that our denominator is a rational number. But in some cases it's necessary to rationalize a numerator, which you'll see in the second example of this video. So let's start with taking a look at this example. The limit as x approaches 0 of x divided by the square root of x plus 9 minus 3. And we notice that direct substitution causes us to get 0 divided by 0 plus the square root of 9. So that's the square root of 9, which is 3 minus 3. So direct substitution would get us 0 divided by 0. In this case, what we'll do is we're going to simplify our rational expression by multiplying the numerator and denominator by the conjugate of our denominator. Notice the conjugate of the square root of x plus 9 minus 3 is the square root of x plus 9 plus 3. So we'll multiply the numerator and denominator by this conjugate. And now then, we'll have the limit as x approaches 0 of x times the square root of x plus 9 plus 3. Just wait to distribute this numerator. We are going to distribute our denominator, though. Notice that we've got this a minus b times a plus b formula, which we know gives us a squared minus b squared. In this case, a is equal to the square root of x plus 9, and b is equal to 3. So we will get over here the square root of x plus 9 squared minus 3 squared. And now we'll work on simplifying our expression. We have the limit as x approaches 0 of x times the square root of x plus 9 minus 3, all divided by the square root of x plus 9 squared is just x plus 9 minus 3 squared, which gives us 9. In the next line, our 9's will reduce, so we have the limit as x approaches 0 of x times the square root of x plus 9 minus 3 divided by x plus 9 minus 9 gives us x, which is the same thing. I'm going to go to the right as the limit as x approaches 0. Notice in this case, in this line, we have x divided by x, and x divided by x is 1. So our x's will reduce out, and we'll be left with the limit as x approaches 0 of the square root of x plus 9 minus 3. Whoa, 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 whoa. Do you see what I did? Ay, ay, ay. Did you catch my mistake? I have plus 3. I multiplied by plus 3. X square root of x plus 9 plus 3. Square root of x 9 plus 3. I got a plus, and then I changed my plus to a minus down here. This should be a plus. This should also be a plus, which makes this a plus. Sorry for the confusion. But notice that when we use direct substitution, 0 can go into our square root function, and we will not get an undefined value back. So we'll evaluate. We'll put 0 in here for x. This becomes 0 plus 9 plus 3, which becomes the square root of 9 plus 3, which we know then the limit as x approaches 0 of x divided by the square root of x plus 9 minus 3 is equal to the square root of 9, which is 3, plus 3 is 6. All right, let's try another example. Here, in the second example, we will rationalize our numerator. So let's try the limit as x approaches 0 of the square root of x plus 1 minus 1 divided by x. So we will multiply by the conjugate of our numerator, which is the square root of x plus 1 divided by the square root of x plus 1 plus 1. This is going to give us the limit as x approaches 0 of, we get our a squared minus our b squared divided by x times the square root of x plus 1 plus 1. So we have the limit as x approaches 0 of the square root of x plus 1 squared becomes x plus 1 minus 1 squared, which is 1, all divided by x times the square root of x plus 1 plus 1, which will equal the limit as x approaches 0 of x divided by x times the square root of x plus 1 plus 1. The x's will reduce here. Next step, we'll be left with the limit as x approaches 0 of 1 divided by the square root of x plus 1 plus 1. And now we're ready to evaluate the limit as x approaches 0 of 1 divided by the square root of x plus 1 plus 1 is the same thing as 1 divided by the square root of 0 plus 1, which is 1 divided by the square root of 1 plus 1, which is 1 divided by 1 plus 1, which is 1/2. Therefore, we know that the limit as x approaches 0 of the square root of x plus 1 minus 1 divided by x is 1/2.